Hello! In this video, we'll be looking at the chain rule. For a composite function f of u, where u is a function g of x, and u prime is the derivative g prime of x, the derivative of that composition with respect to x will be f prime of u times u prime. So the chain rule says to take the derivative of the outer function with respect to the inner function u, and then multiply by the derivative of the inner function u with respect to x. So this is the general chain rule when the outer function f is not specified. Here we have a list of the chain rule versions of the basic derivative rules. Here we have the power rule. If instead of x to the n, you have something else to power n, you can use the chain rule version of the power rule. It will be n u to the n minus 1 times u prime. Also, for the chain rule versions of the derivative rules for the trig functions, you can see that the rules are the same as the basic rules, except that x is replaced with u, and we multiply by u prime after. To begin using the chain rule, identify what the outermost function is, and call the inside of the outermost function u. In this example, we have x cubed plus 1 all to power 8. Here the outermost function is the power 8, and then we can call the inside function u. So here we will take the derivative of u to the 8, using the chain rule version of power rule. So the derivative of u to the 8 will be 8u to the 7 times u prime. So the derivative is 8u to the 7 times the derivative of the u. So the derivative of x cubed plus 1 is 3x squared. 8 times 3x squared will bring it in the front. So we have 24x squared times x cubed plus 1 to power 7. Next we have the function 3 divided by 5 times the cube root of 6x squared plus 1. Here we can bring up the cube root of 6x squared plus 1. We can rewrite it with a negative fractional exponent. So we'll have 3 over 5 as a constant times 6x squared plus 1 to the power minus 1/3. So here we don't just have x to the power minus 1/3. We have 6x squared plus 1 to the power minus 1/3. So we know we have to use the chain rule. The outer function is the power minus 1/3, so we'll take the derivative of u to the minus 1/3. The derivative of u to the minus 1/3 is minus 1/3 u to the minus 4/3 times u prime. So we'll keep the 3/5 in the front. We'll have minus 1/3 u to the minus 4/3, and then we'll take the derivative of the u. The derivative of 6x squared plus 1 is 12x. 3 and 3 will cancel. So we have negative 12x over 5 times 6x squared plus 1 to the minus 4/3. And you can also rewrite it back in the radical notation. The power is negative, so it will go in the denominator. And it's to power 4 and cube rooted. So we have the cube root of 6x squared plus 1 all to power 4. In the next example, find the x values where this function has a horizontal tangent line. So a function has a horizontal tangent line where the derivative or slope is equal to 0. So we'll want to take the derivative of 5x plus 4 cubed divided by 2 minus 3x to power 5. So quotient, we'll use quotient rule. And we'll also have to use the chain rule when we take the derivative of the top or the derivative of the bottom. On top we have 5x plus 4 to power 3. So since it's not just x cubed, it's 5x plus 4 cubed, we'll take the derivative of u cubed. Also for 2 minus 3x to power 5, since it's not just x to the power 5, it's 2 minus 3x to power 5, we'll use the derivative rule for u to the 5. So when we use the quotient rule, we'll have the bottom squared, and then a copy of the bottom in the numerator. Then we'll take the derivative of u cubed, which will be 3u squared times u prime. And then we'll have a copy of the top. And then for the derivative of the bottom, we'll take the derivative of u to the 5, which will be 5u to the 4 times u prime. So that's the derivative, and next we'll simplify. We can take out the common factors to the lowest power that they appear in any of the terms. So for common factor 2 minus 3x, we'll take it out to power 4. We can also take out 15, and we can also take out 5x plus 4 to power 2. So here in the front, we factored 15, 2 minus 3x to power 4, times 5x plus 4 to power 2. Then in the big bracket, we are left with 2 minus 3x plus 5x plus 4. So if we add up the like terms in the big bracket, 5x minus 3x will be 2x, and 2 plus 4 will be 6. Also, we can cancel 2 minus 3x to power 4 from the top and bottom. So then we are left with 2 minus 3x to power 6, since 10 minus 4 is 6. And finally, we have a common factor of 2 in the bracket 2x plus 6, so we can take that out in the front, and 15 times 2 will be 30. So we can set the derivative equal to 0 and solve for x. It will be 0 only when the top is equal to 0, since nothing in the denominator can make it 0. So we're looking for the values that make the top equal to 0, and the top will be equal to 0 when any of the factors is equal to 0. So here we're using the zero product property. So 30 can never be 0, and the next factor, 5x plus 4 squared, will be equal to 0 when 5x plus 4 is equal to 0. This is when 5x is equal to minus 4, or x is equal to minus 4/5. And the other factor, x plus 3, will be equal to 0 when x is equal to minus 3. And just for reference, here's a graph of the original function. And you can see the horizontal tangent lines in red at the x values minus 3 and minus 4/5.